Right, here we go, here we go. Listen, man. Hey, guys, I hope you guys had success with yesterday's lesson. We're going to get right into it today. Straight into the numbers, straight into working this out. Our objective for today, if you can't see it, is students will convert negative numbers between scientific and standard form. Now, that negative numbers is a little misleading. It's more so dealing with negative exponents. All right, yesterday we dealt with the positive version and the positive exponent. So I don't want you guys to think necessarily negative numbers, but you can already tell the difference between the number that we had yesterday and what we got today. So let me count these zeros really quick, and we'll work this out. All right, boom. All right, we back at it. Here we go. Yeah, y'all wasn't ready for that. I already know. All right, so here we go. I got this number on the board. What does it? This is the standard form, and we need to convert that to scientific. All right, so this principle still is the same as yesterday. This decimal point needs to stop in between these two digits. There should always be one number to the right, to the left of the decimal point in scientific notation. So now what I'm going to do is I'm going to loop-de-loop and count like I did yesterday. All right, I'm about to loop-de-loop and count like I did yesterday. So here we go. Here's my loop-de-loop. So we got 1, 2, 3, 4, 5, 6, 7, 8, and then we got 9. Nueve, baby. Nueve. All right, so now that number becomes 4.79 times 10, and it's not going to be to the 9th power, but it's going to be to the negative 9th power. All right? All right, any questions? Now that was simple. That was real easy. All right, so let's take a look at our next example. Right, bam. Next example is on the board. All right, so what do we need to do? Remember, it's going to go right here in between those first two sets of numbers. All right, we're gonna loop-de-loop. 1, 2, 3, 4, and then 5. All right. So my scientific form is gonna be 9.156 times 10 to the negative 5th power. It's real easy, guys. This is it's not rocket science. It's really easy. Let's check out our next example. I hope that you guys are getting this because I'm going through it fast. Okay, I just went and put the last 3 on here. Remember, it needs to go right here in between here. This one needs to stop right here. I hope you guys are getting this and taking notes. And listen, it goes after the last non-zero digit. So I don't want to put it between 0 and 7 here. Actually, I'm going to do that one last. Actually, no, I'm going to talk about it now. It goes after the last non-zero. After the last non-zero. So if you're looking at this example, I don't have any digits after that 7, but these are zeros. Remember, scientific notation, the number in the ones place has to be between 1 and 10. Okay? So I can't have a 0 right there. Let me say that again. In scientific notation, the number in the ones place, meaning 3.79, this number has to be between 0 and 10. You can't have 13.95 and be in scientific notation. You can't have 0.76 and be in scientific notation. This number has to be between 0 and 10. All right, now that I done said that, let's get to it. I'm going to do this one first. So, we're going to loop-de-loop. Here we go. 1, 2, 3, 4, 5, 6, 7, 8. 8. So that would become 8.5, and I don't have to put the 0, but I can if I want to, times 10 to the negative 8th power. Okay? Now, I said I don't have to put the 0. If this would have been 0, 1 at the end, then I got to include that 0, 1. But if there's no other numbers and it's only a 0, I can leave that off. All right? Next one. Same principle. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So that's going to become 5.94 times 10 to the negative 12th power. Y'all, this is real easy stuff, man. Real easy stuff. This last one. Can y'all see that up there? Whoop. Here we go. 1, 2, 3, 4, 5, 6. And after the first non-zero, 7. So we got 7 times 10 to the negative 7th power. Remember, you got to stop after the first non-zero. First non-zero. First non-zero. All right. So this is what I want you to do. I want you to now pause the video, and I need you to meet me in the kick. All right. You're going to meet me in the kick. Meet me over in class kick. All right. Pause the video. We back live, baby. We back live. All right. So I hope that you guys had success with that. If you're here, you probably did because I told you go ahead and go back to the video. All right. So now, with these negative exponents, this number should be getting smaller. So when you see the negative exponent, this is a rule of thumb. Anytime you see that, the number should get smaller. If the number got bigger, then you went the wrong way. If the number got bigger, you went the wrong way. I'm going to say it a third time. If the number got bigger, you went the wrong way. So if I'm doing this problem and I'm going this way, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and I get 6, 0, 0, 2, and 1, 2, 3, 4, 5, 6, 7, I'm just going to make up something. If this is a bigger number, and it shouldn't have gotten bigger because the exponent is negative. So if the number got bigger, what I'm telling you, are you hearing what I'm saying? Do you understand the words that are coming out of my mouth? If the number get bigger, then you went the wrong way because that exponent is negative and it should be getting smaller. All right. I hope you got that because I ain't saying it no more. I'm going to move to the left. For positive exponents, we move to the right. We did that yesterday. This is negative. We're moving to the left. How many times? 10 times. Here we go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Decimal point goes right here. Can you see that? So, decimal point right here. So I got 0 points. Decimal point. How many zeros? 1, 2, 3, 4, 5, 6, 7, 8, 9. So that is, the answer would be 0 point with 9 zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9, 6, 0, 0, 2. That's that number standard notation. Let's move to the next one. We moving. If you getting this, let me hear you say I got. Well, no, y'all better not say I got it, because if y'all yelling in my Google Meets, I might yell back at you. All right, here we go. 10 to the negative 13th. Here we go. We're going to move to the left or the right? To the left. Yeah, to the left now, y'all. 2 ops this time. All right, we ain't going to cha-cha. Here we go. Real smooth. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Decimal point here. 0 point. How many zeros are going in between here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So my answer is 0.12 zeros. 315. That's the number in standard notation. Okay? Moving on. Said we moving on. Here we go now. All right. So let's move this down just a little bit. See how see that? Boom. Got that? See that? Oh, it's my bad side. Here we go. So we're moving to the left 9 times. 1, 2, 3, 4, 5, 6, 7, 8, 9. All right. 9 times. 0 point. How many zeros? 1, 2, 3, 4, 5, 6, 7, 8. So there's 8 zeros. So our answer is 0 0.1, 2, 3, 4, 5, 6, 7, 8. And then we got 504. All right. 504. That's that 504. You heard me? That's that 504. You don't know nothing about that 504. All right. So listen. That's it, guys. I'm not going to go through any more examples. What I want you to do now is meet me over in the kick. Go ahead and meet me in the kick. Hit me up in the kick. Yeah, that's my Star Wars show, you know, for my son's birthday. Yeah, had a good time. Anyways, go ahead and meet me in the kick, guys, and we're gonna work on this and we're gonna practice this, and I'll catch you guys next time. Holla!